Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the points. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the location of a point available with us into the second quadrant, and now we are required to obtain the front view, top view, left hand side view and the right hand side view orthographic projections of a point. Here we have been provided with horizontal plane, the vertical plane and the profile plane into a 3D spatial arrangement, and we can observe over here that this is the location of quadrant number 1, this is the location of quadrant number 2, this is the location of quadrant number 3 and this is the location of the quadrant number 4. So whenever an object or a point happens to lie into second quadrant, so we will observe that the object will be lying behind the vertical plane and above the horizontal plane over here. So here we can check, this is the horizontal plane available with us, this is the vertical plane available with us, and this is the profile plane which is available onto the left hand side. This is the profile plane which is available onto the right hand side. Now we can check whenever an object is available into the quadrant number 2. So we will observe that object will be lying above the horizontal plane and behind the vertical plane over here. So this is the spatial location of the object or the point into the second quadrant. And whenever we are going to look at this object from the front view orientation, then the front view orthographic projection of this point will be available onto the vertical plane. Similarly, when we are going to look at this object from the top view orthographic projections of this point will be available onto the horizontal plane, and we can check that this vertical plane front view projection and this horizontal plane top view projection, both of these projections, they are available with us into the mutually perpendicular planes over here. Similarly, when the object is lying into the second quadrant, when the observer is going to look at this object from the left hand side, so the projection of this point B or the object will be available onto the left side profile plane available over here. Similarly, when the observer is going to look at this object from the right hand side view orientation, so this object B will be having its side view projections available with us onto the right hand side view profile plane over here. Now we can observe that the left hand side view orthographic projections, the right hand side view orthographic projections, the top view orthographic projections and the front view orthographic projections, they are all available into the mutually perpendicular planes over here. But the orthographic projections corresponding to this point we are required to obtain into a two-dimensional plane sheet over here. So how that will be possible? That will be possible by rotating different reference planes into the designated rotation orientations over here. So we can check this horizontal plane portion which is going to lie in front of the vertical plane, it is to be rotated in the clockwise direction, that is into the downward direction, whereas the portion of this horizontal plane lying below this vertical plane, it has to be rotated again into the clockwise direction. But behind the vertical plane, this clockwise direction means that the horizontal plane should be rotated in the upward direction over here, so that there will be overlapping of this rotated horizontal plane with the vertical plane over here. Similarly, the left side profile plane, it also needs to be rotated in such a way that this front side of vertical plane, whatever portion of the profile plane will be available, it will be rotated into this orientation about this hinge over here. Similarly, the portion of this profile plane in front of the vertical plane, it will be rotated about this hinge towards the right side direction over here. But this portion of the profile plane which is available behind the vertical plane, it will be also rotated about this hinge into this orientation towards the left hand side direction over here. And again, this portion of the right side profile plane which is available behind the vertical plane, it will be rotated about this hinge over here towards the right hand side direction over here. So now we can check after the rotation what is going to happen. As the observer is going to look at this object from the front view projections of this point B will be available above the XY reference line. Similarly, the top view orthographic projections of this point which are available with us onto the horizontal plane, and as this horizontal plane will be rotated in the upward direction, so once again the top view orthographic projections, they are going to coincide with the front view orthographic projections above the XY reference line. Similarly, when the observer is going to look at this object from the left side orientation, now we observe that the left hand side view projection of this point B will be obtained on the left side profile plane. This will be rotated towards the left hand side orientation about this edge. Now we observe that the left side orthographic projections of this point B will be obtained on the left side of the front view orthographic projections above the XY reference line over here. Similarly, when the observer is going to look at this object from the right hand side view orientation, so the projections of this point B will be available onto this right profile plane, and since this right profile plane will be further rotated towards the right hand side, so we are going to obtain the right side projections of this point B towards the right side of the front view projections above the XY reference line. Now let us observe the pattern of unfolding of all of these views into the second angle projection method over here. Now we observe that when the object is located behind the vertical plane and above the horizontal plane, so we are going to assume that the object is going to lie into quadrant number 2 over here. And as we have already discussed, into the quadrant number 2, the portion of the horizontal plane which is lying behind the vertical plane, it will be moving in the upward direction, and it is going to coincide or supersede upon this vertical plane over here. And this left side profile plane, it will be opening towards the left hand side orientation about this particular hinge over here, and this right hand side view profile plane, it is going to open into this orientation towards the right hand side orientation about this hinge available over here. So now as we are going to open out these three planes of projection, so we will observe that horizontal plane, it is moving upwards or the clockwise direction. Left side profile plane, it is moving towards the left side orientation, and the right profile plane, it is moving towards the right hand direction over here. So this way we are going to observe the overlapping of the front view and the top view orthographic projections above the XY reference line. The left hand side view projections of the object will be obtained on the left hand side of the front view projections above the XY reference line, and the right hand side view projections of the object will be obtained on the right hand side of the front view projections above the XY reference line. So this way we have been able to obtain the spatial arrangement of all of these planes of projections with respect to the XY reference line. So let us discuss the orthographic projections of a point B which happens to lie 35 millimeter above the horizontal plane and 25 millimeter behind the vertical plane into the second quadrant. So we have located point B into quadrant number 2. Now when the observer is going to look at this point B from the front view orientation, so we observe that the front view projection, that is the elevation projection of this point B, will be obtained as point B dash located onto the vertical plane in such a way that this point B dash will be available at a distance of 35 millimeter above the XY reference line available over here. Similarly, when the observer is going to look at this point B from the top view orientation, so we observe that this point B will be projected appropriately onto the horizontal plane at a point B which is located at a distance of 25 millimeter from the vertical plane. But both of these orthographic projections, they happen to lie into mutually perpendicular planes, whereas we are required to draw the front view and the top view projection onto a simple plain piece of paper over here. So what we have to do in order to obtain both of these mutually perpendicular projections into the 2D plane projection over here, so we are required to rotate this portion of the horizontal plane which is lying behind this vertical plane into the clockwise direction or the upward direction. So we observe that there will be overlapping of this horizontal plane with the vertical plane. So now we know that this distance of point B from the XY reference line, it happens to be 25 millimeter. So with this point as our needle point, we will open the compass is equal to 25 millimeter and we'll draw an arc into the clockwise direction or the upward direction, so that this top view plan projection of this point B obtained onto the horizontal plane, it will be transferred appropriately through this rotation onto this vertical plane. So now we are able to obtain both front view orthographic projections and the top view orthographic projections above the XY reference line. Now let us obtain the projections of this point B onto the left side profile plane. Now we already know that this left side profile plane, it will be open towards this side. So now when the observer is going to look at this point B or the object from the left hand side orientation, so we observe that this point B, it will be projected onto the left profile plane at a point which is called B double dash, and this point B double dash will be located at a distance of 35 millimeter from the horizontal plane and 25 millimeter from the vertical plane over here. Now the projections we have obtained over here onto the left profile plane, they will be called as left hand side view projections over here. Now let us obtain the right profile plane into the 3D spatial arrangement over here. Now when the observer is going to look at this object from the right hand side view orientation, we observe that the side view projections of this point B onto the right profile plane will be obtained at this particular position, and the point will be obtained as B double dash, which is the side view. And since the observer is looking at this object from the right hand side orientation, so the name of the projections which are obtained onto the right profile plane, they will be called as right hand side view projections of the point B over here. And once again, this point B double dash, it is available with us at a height of 35 millimeter from the horizontal plane and at a distance of 25 millimeter from the vertical plane. Now let us establish the relationship between front view projections and the side view projections over here. So this is the front view projection B dash. This is the side view projection B double dash, that is left hand side view, and right hand side view projections over here. Now once we draw these three projector lines over here, we observe that the front view projections and the right hand side view and the left hand side view projections, all three of them, they are available at a height of 35 millimeter above the horizontal plane over here. Similarly, when we draw these three projector lines over here, we can check. So we observe that we are able to establish the relationship between top view projection and the left hand side view and the right hand side view projections over here. What is this relationship between these three? That is, all three of them, they are available at a distance of 25 millimeter away from the vertical plane. So this way we have been able to obtain front view orthographic projections, top view orthographic projections, left hand side view orthographic projections, and the right hand side view orthographic projections into the 3D spatial environment. Now we know that as we have rotated horizontal plane in the upward direction, we also need to rotate left profile plane towards the left orientation about this inch. Similarly, we also need to rotate the right profile plane toward the right side direction about this particular hinge over here. So now let us proceed to evaluate the two-dimensional orthographic projections of this point B onto a single plane over here. So we have drawn the XY reference line and we have also obtained the X1, Y1 reference line corresponding to the left side profile plane. Again, we have drawn another X1, Y1 reference line corresponding to the right side profile plane over here. So this area will be the vertical plane where the front view orthographic projections will be obtained. So as we know that horizontal plane has to be rotated in the upward direction. So the horizontal plane will also be available over here, onto which the top view projections we are going to obtain. So depending upon the distances from the horizontal plane and the vertical plane, so the location of B dash and B will be defined above the XY reference line into the second angle projection method over here. Now onto this side, the left hand side view projections will be obtained. Onto this side, the right hand side view orthographic projections of the point will be obtained over here. So now this is the transfer line which will be used to obtain the distance from the vertical plane into the side view projections over here. Similarly, this is also the transfer line which will be used to project the distance from the vertical plane into the right hand side view projection view over here. Now we know that the distance of this front view projection point B dash above the XY reference line or above the horizontal plane happens to be equal to 35 millimeter. So to begin with, onto the vertical plane, we have been able to obtain front view projections B dash in such a way that this point B dash will be located at a height of 35 millimeter above the XY reference line or above the horizontal plane. Moreover, we also know that the height of this top view projection above the XY reference line, it happens to be equal to 25 millimeter because the distance of the point B from the vertical plane happened to be equal to 25 millimeter. So now at a height of 25 millimeter above the horizontal plane onto the same vertical projector line, we have been able to obtain top view or plan projection point view as point B over here. Now let us plot the left hand side view projections and the right hand side view projections over here. So now we know that B double dash point, it is available at a height of 35 millimeter above the horizontal plane. So now from point B dash, which is the front view projection onto the vertical plane, So we are going to draw a horizontal projector line into the left side profile plane. So this is the left side profile plane. So this area happens to be our left side profile plane. So we have marked a distance of 35 millimeter above the XY reference line, and a horizontal projector line we have drawn through this locus of point B dash over here. So how do we transfer this distance 25 millimeter corresponding to the distance of point B from the vertical plane? So now we can check through this point B. Again, a horizontal projector line we have to draw, and wherever this horizontal projector line at a distance of 25 millimeter from the vertical plane, it intersects with this transfer line. So this distance of 25 millimeter from the vertical plane, it has to be transferred in the perpendicular direction as a vertical projector line over here. So now this distance is 25 millimeter from the vertical plane, which has been transferred above the XY reference line over here. So now this distance we are required to transfer using this transfer line in such a way that this distance from the vertical plane will become equal to 25 millimeter over here. So now this vertical projector line, it will depict this horizontal distance of 25 millimeter from the vertical plane into the left hand side view profile plane over here. So now into the left hand side view profile plane, this vertical projector line, wherever it intersects with this horizontal projector line obtained at a height of 35 millimeter above the horizontal plane, so this point of intersection will be termed as point B double dash, which happens to be the left hand side view projection of this point B onto the left profile plane over here. Let us obtain the right hand side view projections of this point B double dash onto the right profile plane. So once again, we know that this point B double dash is available at a height of 35 millimeter above the horizontal plane. So now through this point B dash, let us draw a horizontal locus line and extend it into the right profile plane area over here. So this height will designate the height of point B double dash into the right hand side view projections over here. So let us obtain the distance of 25 millimeter from the vertical plane. So now we know that location of point B, that is the top view projections from the vertical plane, it happens to be 25 millimeter. So through this point B, again a horizontal projector line will be extended up to the transfer line into the right profile view projections over here, so that wherever this horizontal projector line drawn through the point B, it intersects with this transfer line. Now this horizontal distance will indicate the distance of the profile view projection from the vertical plane over here. This is the vertical plane. This is the distance of the point B double dash from the vertical plane. And now once we extend this vertical projector line upwards, so wherever this vertical projector line drawn upwards will be intersecting with this horizontal projector line drawn through the point B dash, so we will be able to obtain point B double dash into the right profile plane, and the name of this projection will be right hand side view projections over here, because the observer is looking at this object from the right hand side view orientation over here. So this way we have been able to obtain front view orthographic projections, the top view orthographic projections, the left hand side view orthographic projections, and the right hand side view orthographic projections of a point B which happens to lie into the second quadrant over here. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of projections of the points in the coming lectures. So thank you very much. Thanks a lot.